Up until now, the only data structure we have discussed is the array, which allowed you to save a list of data ordered by numeric indices in a specific sequence. However, real-world data has named attributes. A starship isn't just an array of items, it has a name, a crew capacity, and a status. An object is a collection of related data, and we store the data with key-value pairs. Let's take a look at how to create one using an object literal syntax. I'm going to use the const keyword instead of let. Let's say we're describing a ship. We'll give it a name and use a colon to separate the key from the value. Together, those are called a key-value pair. The key does not have quotes around it, but JavaScript is storing it as a string behind the scenes. The value can be any data type you want. For now, we're going to focus on using basic values like strings, numbers, and booleans. You separate your key value pairs using commas. So I'll have a class type and give that a value. It's going to be another string. And then we'll have a crew capacity. And in this case, I'm going to store a number, 4. Our last one is asking if the drive is active. So that's a Boolean value, false. And then you put a semicolon on the end because even though we have written this across several lines to give it a really nice readable format, it is just a constant, so it needs a semicolon at the end. Let's print the object to the console to see how it turns out. And we see our object literal with all 4 key value pairs, also known as properties. So that's all there is to creating and storing data with JavaScript objects. We're going to talk in the future about more complex data structures where we actually nest things like other objects or arrays as values for some of the keys in a greater object, but for now we'll keep it simple. Let's look at example 2. Here we have 2 objects that have different names. They're declared separately. They have the exact same content. They have a key that is the oxygen level and a value of 98. Let's test and see if those 2 things are equal. We'll just log sector A equals sector B and see what we get. Is it going to be true or false? And it turns out it's false. Here's the reason why. While primitives like numbers or strings are stored directly in memory according to that variable name, objects are completely different. The variable doesn't hold the object itself, it holds a reference pointer to a memory address, which means that when we try to compare 2 distinct objects, they're not going to point to the same place in memory, even if their content matches. So these are 2 completely different objects. They were declared separately. What if you create a new constant with a new name and set it equal to one of the existing objects? Let's check and see if those are equal. And we see true. So something interesting that you may not expect is that when you assign an object to a variable name like this, all it does is just point to that original object. So you haven't really created a true clone as a separate object that can be mutated separately. You're just pointing from one to the other. We're going to explore this more in a future demo. So for now, let's just make our git commit. And we'll talk about the practice that you need to do. We have some instructions here for you to create an object literal with a number of different properties about a pilot, and you get to decide what the values are going to be, but the names of the keys are provided here for you. For the second one, you're just told a little bit about the object, and you're going to have to come up with the key name and the value based on this information. Then for this one, you're going to do a little bit of prediction about what's going to happen when you try to alter a property inside Shadow Core and see if the original core has been changed or not. And that's all I've got. I will see you in the next one.